Assalamu alaikum. Welcome to lecture number 22 of Software Requirements Engineering CSC305. And in today's lecture, we are going to continue our discussion on requirement specification. And specifically, we were talking about specifying non-functional requirements. We are going to continue our discussion on that. And if time permits, then we are going to start our discussion on requirements validation as well. So let's quickly recap what we did in our previous lecture. So we started talking about non-functional requirements or specifying non-functional requirements in our last lecture, and generally we talked about that specifying non-functional requirements is slightly difficult in comparison to the functional requirements. And the way we specify requirements, at times it distinguishes between what can become a functional or can be a non-functional requirement. Then we talked about a couple of very interesting things, that how do we derive these non-functional requirements. And generally we said that a client or the end user would specify the non-functional requirements as concerns or goals. Right? So there are two ways of deriving these non-functional requirements. One is through concern decomposition and the other is through goal decomposition. So we said that, for example, an end user might have a concern that we looked at a particular example where we said that an end user might have a concern that he wants to view the air traffic, for example, and now that is one concern. Now, but that does not actually define how we can actually achieve that, or what would be. Or what kind of detail should we put into it. So what we said that was that we decompose this bigger concern. So we say that there are two portions of it. First is that what information does the user wants to see, and how frequently he wants to actually see that information. So those two concerns, we then decompose them further to actually identify and narrow down what kind of display the user wants to see on a screen. And secondly, we also narrowed down that what should be the frequency of getting input from the radar in order to view actually the plane position. And similarly, we talked about that goal decomposition would also work in a similar fashion. We would have a bigger goal. We'll start decomposing it into sub-goals, and to achieve those sub-goals, we'll narrow down some requirements. So if you try to relate it to the functional requirements, then this is actually very similar to something we did in analysis, but we specifically said that the analysis or the elaboration phase is to understand the information domain, the function and behavior of the system, which mainly concerns with the functional requirements of the product. So we need to do something similar for non-functional requirements. So here is what we actually do for these non-functional requirements, that very systematically we try to derive these non-functional requirements from the concerns or the goals that end users has specified. Then another topic that we started discussing in our previous lecture was specifying non-functional requirements for safety critical systems. And we defined that there are three kinds of safety critical systems. One where human life can be in danger, another are mission critical systems, and then we have business critical systems. So it is very important for the safety critical system that these non-functional requirements are met, because something we discussed that at times, or more often than not, the failure of these systems is a result of not fulfilling those non-functional requirements rather than the functional requirement, because the functional requirement, they are always tested and tried, whereas the non-functional requirements, because at times they are not testable. We have seen the example of requirements which are not testable. For example, completeness or correctness, we cannot actually ensure, or it takes human judgment to ensure that that your system actually meets that particular requirement or not. So for safety critical systems, it is very important to specify non-functional requirements in a correct fashion, and this is where we will start our today's lecture again. So in our lecture today, we are going to start discussing how we specify these non-functional requirements for safety critical system. We'll continue where we left in our previous lecture. And then, if time permits, as I already said, we are going to talk about requirements validation, and we are going to see what, as a process, this validation process, what it entails in detail, and where in terms of overall requirement engineering process it begins and where it stands. So before we get to it, let's quickly recap what we did in terms of non-functional requirements for safety critical systems. So we said a failure of a critical system may result from a failure to meet a functional requirement, but more often it results from a failure of the system to satisfy some non-functional constraint on its operation. Now one thing, another thing that we discussed in our lecture was that that these non-functional requirements, they are actually constraints on the functionality and behavior of the product. So at times, as I said, that it is very easy to test the functional requirements, and normally we write functional requirements in a fashion that they become testable, or it's very easy to actually test them, whereas non-functional requirements, that's not the case. So because they are not thoroughly tested, so they can result in failure of the systems. So we need to understand that what are the important categories of these non-functional requirements and how do we actually specify them. So the principal non-functional constraints which are relevant to critical systems are reliability, performance, security, usability, and safety. So these are the 5 concerns which are of real importance for safety critical system. We will talk about reliability. We have already talked about what reliability means. We have already talked about what performance means, what security, usability, and safety means. But in terms of these safety critical systems, their importance is magnified, because if system is not reliable, or if it's not actually performing the way user actually desires, or it's not actually up to speed with the way user wants to input some very key data in, so the system would simply fail. So for safety critical system, the importance of these non-functional requirements is a lot in comparison to any other system. So what does reliability mean in terms of the safety critical system? These are constraints on the runtime behavior of the system. So we already know that all of these non-functional requirements, they are constraints on the runtime behavior of the system. They can be considered under 2 separate headings: availability and failure rate. So there are 2 terms which can be interchangeably used at times. Availability is the system available for service when requested by the end user. So we want the system to be available whenever a user wants to input something. So for example, where our system should be up if system has to pull some data from somewhere, then the system should always be up getting that information. For example, if let's say there are some sensors deployed and they are sending some very critical information to the system 24/7, then our system should be available 24/7. If it's not, then maybe we will miss some very key information. And second is the failure rate. How often does the system fail to deliver the service expected by the end user? So you see, they are very similar, or they can be used interchangeably. One, we are saying that what is the frequency of the time when the system is actually available, and failure rate, we are saying that that how often does the system fail to deliver the service expected by the end user. So these reliability requirements can often be expressed quantitatively. So we need to specify these requirements quantitatively. I have been emphasizing on that, and imagine that for these safety critical systems, it is more important. So availability may be specified in terms of the times when the system is unavailable for service. For example, 3 minutes in 24 hours. So we have to specify the time of availability for our system. So we'll say, okay, our system won't be available in this portion of the time, and then we need to be very specific that what that time is, and we need to ensure that after that time system is available. For example, you can set aside some time to take backups, or so in order to do that, you need to specify the time that when your system won't be available, and that needs to be specified, and you need to ensure that system is available after that. And similarly, the failure rate can be specified in this fashion. The acceptable failure rate may be specified in terms of the rate of occurrence of failure in the given time period, or the mean time between failure. So both these cases of availability and failure rate, they can be quantitatively specified, and we need to ensure that when we are writing these requirements, we are expressing them in these terms. If it comes to availability, then we need to tell the time when our system won't be available. And if you're talking about failure rate, then there are 2 ways of actually expressing that quantitatively. One is that we say mean time between failure, and the other is rate of occurrence of failure. So we need to use these terms when we are specifying non-functional reliability requirements for safety critical systems. So next up is performance. Again, these are the constraints on the speed of operation of the system. The first one are on the runtime behavior of the system, and this is on speed of performance of the system, because we desire our system to have certain speed. So there are multiple types of these performance requirements. We have response requirement, we have throughput requirement, and then we have timing requirements. So what is a response requirement? It specifies the acceptable response of the system to the end user input. So as the name suggests, that the end user, they expect certain response from our system. So we need to ensure it in a quantitative fashion. We need to express it or specify it in a quantitative fashion, that what is the desired response rate from my system. So what we can say is that it might be specified that the system should respond to a user request for service within 2 seconds. So we need to quantitatively describe it, and we need to strictly follow it. Then we have these throughput requirements, which specify the amount of data which must be processed in a given time. For example, it might be specified that the system must process at least 10 transactions per second. So we have response requirement, then we have throughput requirements, and then finally we have these timing requirements, which specify how quickly the system must collect input from the sensors before it is overwritten by the next input value, or which specify how quickly outputs must be produced for processing by other systems. For example, it might be specified that the system must poll sensor at least 6 times per second. So you imagine that these 3 kind of performance requirements, they actually encompass all the performance related issues of the product. We are saying that what is the response of our system in terms of the user wants to enter some information into my system. Similarly, we are saying that what is the throughput, how many transactions my system can process in a given time, and then finally we're saying what are the timing requirements. If we want certain output to be produced by the system, or if we want certain operation to be performed by our system, we need to actually time it. So these are the 3 kind of performance requirements that we can specify for safety critical systems. Next is security. Security requirements are included in a system to ensure unauthorized access to the system and its data is not allowed. So you don't want anybody who is not authorized to access your system or the data stored in it. Ensure the integrity of the system from accidental or malicious damage. So what are the examples of these security requirements? So the first up, we have the access permission for the system data may only be changed by the system data administrator. All the system data must be backed up every 24 hours, and the backup copies stored in a secure location which is not in the same building as the system. All the external communication between the system's data server and the client must be encrypted. And there are lots of new technologies which are being proposed for securing your data and securing your documents and securing the access to your data. So, but this is very important in terms of the safety critical system, as at times, normally for every system we have a very simple functional requirement that we want an authentication procedure. Okay, so we want all the users to be given a login name and a password, and they can only access the system or access the data through that login and password. But for safety critical system, we need to have some other requirements as well, because we are saying that that the rights or the access to the system can be only changed by the system administrator. So that is similar to maybe any other system. But then we are saying that that all the data should be backed up. So we are saying that after every 24 hours we need to back up our data, and when we are backing up this data, we are not storing it in the same building, we're storing it somewhere else, because the data is very important and we cannot afford to lose it. And similarly, we are also saying that we need to store our data in an encrypted form, so that only the people who has the decryption key, only they can access it. So again, in terms of security requirements for any other software and safety critical system, we need to actually identify that what is important to my safety critical system. Is the data of real value? Is it really important? Then we need to specify these kind of requirements. So we need to specify that after what amount of time we will be backing up our data, as it is said in this slide, that after 24 hours we will be backing up our data. And similarly, we are saying that all the external communication is encrypted. So maybe when we are putting in more detail, we will actually specify that what kind of encryption algorithm we are going to use. So you can also go into a lot of detail, but that is kind of more implementation to concern. But you can think about these things as well. So it depends on the importance of the data of your system, and then you actually start specifying these kind of requirements. So next up is usability. It is concerned with specifying the user interface and end user interaction with the system. So for example, you can say that we will have well-structured user manuals, informative error messages, help facilities, and consistent interface, enhanced usability. So normally when you're specifying these requirements which concern the end user interface, your main goal is that the product that you're making is very usable for the client, and it has all the information that the client need to use the system. For example, very often you're using for example you're using Microsoft Word, and there are lots of things that you need help with. For example, you're using Excel, you're not sure what the syntax of a particular formula is. Then we go to help and we search the formula, and it's right there, and you can very easily look it up. And the importance of this information is increases for the safety critical system, because we cannot have delays at times. Okay, for example, user is stuck somewhere and he has to punch in some very key information, but he's not been able to access something in the system. So it should be well documented, so that if a user is not being able to figure it out, then he can actually look at in the documentation and try to understand what the problem is. Similarly, if there is an error message, then the error message should be detailed, so that it actually tells the user or gives him a real clue that what was he doing wrong. So again, we specify these usability requirements for any other system. For example, even if we are making a very simple website, we might have usability requirements for that. Or even if we are making a point of sale system for a small shop, we will have usability requirements for that as well. But in terms of defining these usability requirements for safety critical systems, the importance of these things actually increases a lot. So it is way more important to have a well documented user manual. Similarly, it is very important to have detailed error messages for safety critical system, because we want to properly guide the end user. We don't want him to just wait and try to figure it out on hit and trial basis. We want to tell him, okay, this is what you're doing wrong, do it in this fashion, and then you will be able to solve the problem. So that is why the importance of these requirements actually increases for safety critical systems. So finally, what are these usability matrix? So measurable attributes of usability requirements include entry requirements measured in terms of years of experience with class of application or simply age. Learning requirements denotes the time needed to learn the facilities of the system. This could be measured in terms of speed of learning, say hours of training required before independent use is possible. Handling requirements, they denote the error rate of the end user of the system. This could be measured in terms of the errors made when working at normal speed. And likability denotes niceness to use. The most direct to measure user satisfaction is to survey actual users and record the proportion who like to work with the product. So we have some matrix through which we can actually quantitatively gauge that whether my system is usable or not, and therefore we have these entry requirements where we are saying that what is the level of experience of the people who can actually use this system. Then we have some learning requirements where we can actually time that, how long it takes the people to get up to speed with using this particular system. And then we have handling requirements where we try to record that how many mistakes do the people make when they actually start using this system at normal speed. And finally, we have likability, that in general, what is the perception, whether the end user, they like the system or not. And normally it is being said that surveys or through questionnaires or interviews is the best way to actually do this likability analysis, where you basically circulate a survey and try to figure out whether people actually like the user interface or whether they find that the product is easy to use or not. So next up we have safety requirements for safety critical systems, and generally there is no consensus that what is meant by these safety requirements. Sometimes they are considered to be all the requirements, functional and non-functional, on safety related systems. Sometimes the subset of these requirements which are directly related to ensuring safe operation, and sometimes requirements on protecting systems which are designed to protect against accident. So it's very hard to define the safety requirement. So in general, for example, let's imagine that you have deployed a software in a car. So you want to ensure that your software works in a fashion that it does not cause any safety hazard. Okay, but there is actually no way of saying that what are the safety requirements. So it's kind of really hard to specify, but depending on what product we are talking about, so we can actually figure out to some extent that for this particular product what would be my safety requirements. So usage of this term often depends on the culture and practice of the organization. So it is very important that depending on which client you are working for and what type of organization you have, so safety requirements would be outlined very clearly. For example, if you are writing something for a chemical plant, then they would have very strict safety rules, and they would be specified very clearly. So it depends on the type of organization with which you are working and type of organization where you are working as a requirement analyst. But generally, it's a term which has no strict definition that what does safety actually means. So here is an informal definition of safety requirements, that safety requirements are the shall not requirements which exclude unsafe situations from the possible solution space of the system. Now, as we discussed the example of, let's say that we have written a software for a vehicle, and now the unsafe situations can be that the brakes fail and the car crashes. For example, that is just one scenario. Now, our safety requirement would say that this shall not happen. Okay, but again, this whole definition and this example is actually sort of confusing to some extent. But as I said, these safety requirements, they are at times very clearly mentioned, because we are talking about safety critical systems, and for those systems the safety is already defined, that these kind of scenarios, they should not happen. So all those scenarios, they become our safety requirements. So let's look at some of the examples of these safety requirements. So for example, the system shall not permit operation unless the operator guard is in place. Okay, so that is just one example. The system should not allow the sedative dose delivered to the patient to be greater than the maximum value which is determined by the patient's physician. Okay, so again, we know that this should not happen, because because if this happens, then this can be very dangerous. Okay, so we know that this situation already is there. So for example, this particular example where you are giving a sedative dose to a certain patient, now you already know that you have to actually follow the prescription that the physician has actually specified, and you have to only give the dose that is written by the physician. Okay, now that is a safety requirement which is already there. So if we are making a system which automatically actually give that dose to a patient, then our system should not actually exceed that limit. Okay, so that's what I actually meant, that depending on which product you are working for, and because we are talking about safety critical systems, so these safety requirements or these standards, they are already there. So we just need to figure out that what situation should not happen, and all of those, they become actually our safety requirements. And the final example is the system shall not operate if the external temperature is below 4 degrees Celsius. Okay, because we know that if temperature falls below 4 degrees Celsius, then it can cause some catastrophic damage, let's say. So we know that and this already people would know about that, and when you will be designing your system, so you would be told that our system should not work if the temperature drops below 4 degrees centigrade. So this is again in line with what we have just discussed. So that is it from our discussion on specifying these requirements, or specifying non-functional requirements for a safety critical system. We have looked at reliability, we have looked at performance, safety and security, and usability as well. Finally, let's look at some non-functional requirement checklist, and it is important to maintain that, because whenever you are specifying requirements for any product, you need to ensure that you have looked at all these concerns. You need to ensure that you have looked at the reliability concerns, you have looked at efficiency, portability, flexibility. So you need to make a checklist, because as I said that at times these requirements are not clearly specified, and we discussed that even the functional requirement, they are not clearly specified, but they are at least told in terms of user scenarios. But with those non-functional requirements, they are just expressed in terms of concerns and goals, and you can very easily miss that. So it's important to have this checklist and to ensure that you have thought about all these issues very carefully. So number one on that checklist is availability. So we say that a system's availability or uptime is the amount of time that it is operational and available for use. This is specified because some systems are designed with expected downtime for activities like database upgrades and backups. So availability is very important, and we said that reliability can be defined in two ways. It's either availability and failure rate, but availability can be separately defined as well. And it is normally done for those systems where we have to ensure where system is unavailable for a certain amount of time. And normally what happens is that we are working in our offices and we get an email from our network administrator, and he would tell us that the email server would be down for backup for on Saturdays or on Sundays between these times, and they are already planned and they are scheduled backups, because you need to take backups after a certain amount of time, and system is unavailable during that time. So they are already planned. So we need to actually clearly specify that what would be this planned unavailability time of my system. And the second one is efficiency. It specifies how well the software utilizes limited resources. For example, the processor, the disk space, and memory and bandwidth. Then we have flexibility. If the organization intends to increase or extend the functionality of the software after it is deployed, that should be planned from the beginning, because it influences the choice made during the design, development, testing, and deployment of the system. Now, this is again very important, flexibility. I will give you an example from ERP systems, enterprise resource planning softwares. Now, they are normally very huge systems, and the failure rate of these projects is a lot. So when I say the failure rate of ERP projects is a lot, it does not mean that there are no good ERP solutions out there. There are lots of very experienced ERP vendors and suppliers, but the problem is that the problem exists with ERP selection and then with ERP implementation. And we say that if you do not select an ERP properly, then for your organization in particular, then you might end up failing your project. So selecting an ERP is really important, and when you're selecting an ERP, one of the things that you look at, or one of the things that you look at the product, is how flexible is this product. Okay, because you don't want to go and buy a very cheap solution which is not flexible at all. So you want a solution which is flexible enough that, for example, at this particular time you're not interested in one particular module of that ERP. For example, you don't want the HR module, let's say, and but you have already got the sales, purchase, and accounting. So later on you realize, no, I also want the HR module. So if you selected a product which was maybe custom built and which was a very cheap solution for you, it won't work, because you actually didn't think about whether the product was flexible or not. So if you have these intentions, and if you think that you maybe down the line or down the years you're going to increase or extend the functionality of the product, then these requirements, they should be very clearly specified. And then you should look for, in the system that you are actually opting for, that whether the system we are selecting, whether it is flexible or not. Then we have portability. Portability specifies the ease with which the software can be installed on all the necessary platforms and the platform on which it is expected to run. So for example, these should be very clearly defined. So why we are saying that this is the checklist, that once you have written all the requirements, we know these definitions of these, that what is meant by availability, what is meant by efficiency, flexibility, portability. So just look at these definitions and try to figure out that the specifications that you have written, whether it has any information on which platform the system is going to run. If it does not have that information, then we are missing this portability requirements. Similarly, in terms of flexibility, if we do not have anything like it, then we should clearly say that then it would mean that we don't want or we don't intend the functionality of the product to be increased later on. But if there is anything, if there is a desire of doing that, then it should be clearly specified. So it's important to actually look at these definitions and look at your specifications at the end and figure out, okay, I actually missed that. So then it gives you a chance to actually specify them. So next up we have performance. Similarly, the performance constraints, they specify the timing characteristics of the software. So we said there are different kinds of metrics through which we can actually gauge the performance. Certain tasks or features are more time sensitive than others. The non-functional requirements should identify those software functions that have constraints on the performance. As we said that, at times, for example, you have to poll a sensor. So your system needs to poll the sensor, after a certain amount of time. If the system fails to do that, then it would mean that you are missing on some very key information. Similarly, your system might have some timing requirements, and the system might have to produce some output for another system to use, or for end users. And if that report is late, then it can cause lots of damages, and it can cause lots of losses. So it is very important to actually specify the constraints on those features which would affect the performance of your overall system. Then we have reliability. Reliability specifies the capability of the software to maintain its performance over time. And reliable software fails frequently, and certain tasks are more sensitive to failure. So it is very important that we identify those tasks which are more prone to failure. Then reusability. Many systems are developed with the ability to leverage common components across multiple products. Reusability indicates the extent to which the software components should be designed in such a way that they can be used in applications other than the ones for which they were initially developed. So when we are so reusability is also important. Maybe you want when you are developing the product, you want to specify that I want to design these components in a fashion that they are reusable for other projects as well. And then we have robustness. A robust system is able to handle error conditions gracefully without failure. This includes a tolerance of invalid data, software defects, and unexpected operation conditions. So your system should be robust enough. It should not crash every time the user presses an incorrect key. For example, if user presses the login button without supplying the username and password, it should not just crash. It should just give an error that you failed to enter this information. But that is a very simple example of robustness. But robustness generally means that your system should be more robust to failure in general. So then we have three more of these non-functional requirements: scalability, usability, and integrity. So in terms of scalability, we say that software that is scalable has the ability to handle a wide variety of system configuration sizes. The non-functional requirement should specify the way in which the system may be expected to scale up by increasing the hardware capacity, adding machines, etc. And then usability, ease of use requirements address the factors that constitute the capacity of the software to be understood by the end users and learned, and so that the system is very easy to use and they do not make lots of mistakes. And as we just said when we were discussing the usability for safety critical systems, that there are different metrics through which we can actually ensure whether the system is usable or not. And then we have integrity. Integrity requirements define the security attributes of the system, restricting access to features or data to certain users and protecting the privacy of data entered into the software. And we talked about it in terms of security requirements for when we are discussing the NFRs for safety critical systems. So why I discuss this again, this non-functional requirement checklist, is that it is very easy to omit some of these requirements when you are actually specifying or when you are producing the software requirement specification document. If you have this checklist in front of you, and if you go through your requirements that you have specified, all the functional and non-functional requirements, and if you don't find any information which is relevant to this NFRs, and that the user said something about scalability or usability, then you are missing on something. So it is very important to very carefully look at this checklist and look at the specifications and decide which information is actually missing from the requirement specifications that I have produced. So these are some key points to remember about these non-functional requirements. That non-functional requirements, they define the overall qualities or attributes of the resulting system. Non-functional requirements may be classified into three main types. We have already talked about it. We have these product, process, and external requirements, and we said that something about external requirements, that normally these external requirements are those kind of requirements with which our system won't be simply acceptable. So okay, for example, and then we talked about these process requirements as well, that if there are certain standards which the organization follows, we need to actually work according to them. And then we have these product requirements where all these reliability, flexibility, scalability, all these type of requirements, they fit into that category. And then the product requirements, they specify the desired characteristic that a system or subsystems must possess, and they are normally the constraints on the behavior and functionality of your system. Non-functional requirements tend to conflict and interact with other system requirements. So we have already talked about it, that these non-functional requirements, they are going to conflict among themselves. For example, you have a performance requirement, then you have a reliability or a safety or a security requirement, and let's say you want to encrypt your data. Okay, each time you are storing it into a database, but that may affect the performance of your system. It may affect the throughput requirement that you have specified under the performance requirements. So there is a conflict. Now we talked about it, that how do we resolve this conflict? We again rank these non-functional requirements and we try to figure out which of these, whether performance is more important for this system or security is more important for that system. And then we look at the overall goals of the organization. And we see, okay, whether performance relates more to the overall business goals or security relates to the overall business goals. And on the basis of that, we decide, okay, this is more important, so I am going to encrypt my data and I'm not going to worry about the performance even if it degrades a bit. Then the principal non-functional constraints which are relevant to critical systems are reliability, performance, security, usability, and safety. Obviously, the other non-functional constraints, they are also applicable, but these are more important. And we looked at the example of reliability, we looked at performance, we looked at security, usability, and safety. And as I said, we do specify we have these constraints on other systems as well, but for critical systems, the importance of these non-function constraints, it actually increases a lot, because we are talking about, there can be damage to human life, and similarly there can be huge losses, because we have mission critical, business critical, and we have safety critical systems. So it is very important to clearly and very in a quantitative fashion specify these non-functional requirements for safety critical systems. So that is it from our discussion on specifying requirements in general, and specifically in terms of today's lecture, specifying non-functional requirements. Next, we have another requirements engineering process, which is requirements validation. But before we get to it, let's quickly, I like to use this diagram to actually keep track of, that where we are with our course and where we are with our discussion on software requirements engineering. So we did inception in very beginning of our course. Then we talked about elicitation. We looked at multiple elicitation techniques, and we said that because we deploy lots of different techniques, and we take requirements from different stakeholders, and those requirements, they are not properly defined statements, but they are user stories or scenarios. Then we use this analysis or elaboration to actually figure out, okay, what are the requirements for my system, and then we try to negotiate, and we negotiate to come to a consensus that so that with a set of requirements with which all the stakeholders are happy with. And why do we have, or why do we need this negotiation? We talked about it, that because elicitation involves lots of stakeholders, and multiple stakeholders or multiple end users would specify a process from their viewpoint, which would result in conflicts. So we need to resolve these conflicts, and at times a negotiation is not just to resolve conflicts, it's also to rank the requirements, or the conflict can be in form of you want a rank of the requirement, that which requirement is more important. So we talked about this in detail, that how we reach this conclusion, and what is this negotiation process. And then we talked about specification, and within specification we discussed two of the main sub processes of specification process. We said that we specify functional requirements, and then we said we specify non-functional requirements. In terms of specifying functional requirements, we have only discussed that what sort of language to be used when we are specifying requirements, and we spend more time on discussing specifying non-functional requirements, because as I said that normally it is very difficult to specify these non-functional requirements, and because the user, they just talk about them as their concerns, or they just say that we want a product which is of good quality, and so we actually have to figure out for them that what does quality actually mean to them. So if we take quality as a goal, then we will decompose it into sub-goals, and then we'll try to specifically figure out that what do they mean by quality. Okay? Because as I said, that quality is a very subjective term, so we need to objectively write these statements. So that's why we spend more time on discussing that how we come to specify these non-functional requirements. So next up we have this process of requirements validation. And we're going to see that how validation takes input from those previous processes, and what does it produce for the final process, which is the requirement management process of the software requirement engineering process. So before we actually get to it, let's talk about what are the objectives of validation. What do we want to achieve? So it certifies that the requirement document is an acceptable description of the system to be implemented. Very simply, what we mean by validation is that whatever we have specified, we want to ensure that this is what you want. For example, if I am a requirement analyst and you guys are my client, now I have specified the requirement, I've gone through that specification process, I've written the functional and non-functional requirements. Now I want to ensure that I want this document, my SRS document, to be validated by the client. So I will take it to you and I will say, okay, this is what I think you want. Is this what you want? So this is the sole purpose of requirement validation. So normally what a requirement document is checked for is completeness and consistency, conformance to standards, requirements conflicts, technical errors, and ambiguous requirements. Although we have already discussed that during the negotiation process we actually go through this all these bits, that we looked at if there are any incomplete or inconsistent requirements, whether there are any ambiguous requirements, but again, when we are validating requirements, because let's say this is the final document that I have produced, and there are lots of things in it. You know, we have seen multiple templates that we start off with a very general description, then we come to very specific functional requirements and non-functional requirements. So what we are going to do at this stage is, or what the client would do is, client would check this requirement document for completeness and consistency. We will actually ensure that it conforms to all the standards that were specified, whether there are any conflicts in it, whether there are any technical errors in it, or whether there are any requirements which are ambiguous. Because at the end of this process, we are going to actually get this document signed off, and we are going to say, okay, this is what the client wants from me, and I am going to design my system based on this validated set of requirements. I am going to test my system based on this validated set of requirements, and finally, when I deploy my system at the client side and I take approval from the client, I am going to use this document as a baseline. So requirement validation is of utmost importance, and this is a step which is really important. And at times, what new startups they actually forget to do is forget to validate the requirements. So they take a new project, they start working on it, they start delivering the certain deliverables, or they start producing the software, but they don't actually validate this initial set of requirement from the client. And if you don't do that, then you will never be able to get the project accepted by the client, because you know the client would again keep on saying, no, I actually wanted that. So validation is a very key process of requirement engineering process, and we need to very carefully and to ensure that we do this validation properly. So what is this analysis and validation? Analysis works with raw requirements as elicited from the system stakeholder. So there is a difference, because some of the things that you might have seen in this in this slide, we have already talked about them during analysis, and we say that, you know, we do analysis in order to identify all the problematical requirements. So we do analysis to look whether there are any inconsistencies, whether there are any ambiguities, whether there are any incomplete requirements. But there is a difference in validation and in analysis. So what we do in analysis is we work with elicited requirements. So these are scenarios, these are user stories, and we try to figure out that have we got the right requirements. So we actually figure out, or we try to analyze that have we got the right requirements. So this is the key question. Okay. And whereas validation is slightly different. So validation works with the final draft of the requirements document with negotiated and agreed requirements. So we are saying that, you know, these requirements are negotiated and they are agreed upon. So what we write is, or what the main question is, that have we got the requirements right, is the key question to be answered. So there is a slight difference. So the first one is saying that have we got the right requirements, and the second is have we got the requirements right. So we need to, there is a very small difference, and this is very important to understand that although these terms they may seem similar, you know, consistency, completeness, ambiguity, they are at two totally different levels. Initially, we are just trying to ensure that whether we have been able to get the right requirements or not, you know, because we talk to so many people and we are not sure whose opinion actually matters, and you know, there are lots of conflicts, there are lots of ambiguities. So we did negotiation, and through negotiation we actually came to conclusion, okay, this is my final set of requirements. And then I finally started specifying those requirements, and when we specified those requirements, we have a final set of requirement now. Now we need to ensure that, and we need to show them to the client, and we say, okay, are these requirements right? So we need to, that is the question now that we need to answer, because we are going to baseline this, or we are going to use this requirement document to design the system, to test the system, and finally when we are going to take acceptance from you, we are going to take acceptance against these set of features. So there is a slight difference, and do not confuse it that we are again talking about that initial analysis phase where we said we will identify those problematical requirements. So we are not doing that here. We are trying to validate requirements on final set of requirements, not on the basis of user stories or scenarios. So as a process, you know, as I always talk about all these processes in this fashion, that what are the inputs and what is the output from this particular requirements validation process. So there are three key inputs to this validation process. So we have this requirement document, the SRS that we produce. We have organizational knowledge, okay, and we have some organizational standards as well. Right? Because as we said that there are a couple of other things that we want to ensure that my SRS document actually conforms to, and these are organizational standards. So these are also input to this process. And then what is the output of this process? We have list of problems and we have list of agreed actions. So it is, you can say it is similar to negotiation, but it is at a totally different level. Okay. So in terms of validation, we are saying that, you know, we will identify what are the problems in my SRS document, and we will have list of agreed actions as well, that how we are going to resolve this particular situation. So let's look at all of these inputs and outputs in slightly more detail. So requirement documents, it should be a complete version of the document, not an unfinished draft, formatted and organized according to organizational standards. So as a requirement analyst, you know, when I'm going for validation, we have to ensure that the document is actually complete, it is not a draft version, and it is according to the standards that were whether they were specified by the client or whether they are your standards. So it has to conform to all those standards. And then in terms of organizational knowledge, knowledge often implicit of the organization, which may be used to judge the realism of the requirements. And then finally we have these organizational standards, local standards, for example, for the organization of the requirement document. So we need to, all these are the inputs of this validation process. So what are these validation outputs? As I already said, that we will have a list of all those problematical requirements, and similarly we will have agreed actions. So we will agree that, you know, how we are going to solve these problems, and at times we might have several corrective actions for one requirement, and we may not have any, because so it depends, you know, what kind of problem we have figured out in the final specification document. So how do we conduct these reviews? So we have these, how do we actually ensure that, or how we actually validate these requirements is through reviews. Okay. So what does a review entail is that a group of people would sit down, and you as a producer of this document, you will have to present the requirement document. And through this review, people would actually identify and they will figure out, okay, what are the problems with this requirement document. So let's look at that. A group of people read and analyze the requirements, look for problems, meet and discuss the problems, and agree on the actions to address these problems. So you will conduct these requirement reviews, and in terms of software quality assurance, you know, you might have actually already gone through this particular topic of formal reviews and informal reviews. Now, as an organization may have different standards, okay. Different organizations conduct lots of these reviews, and informal reviews, they are normally not timed. And for example, the QA manager, he would ask different people to actually go and review certain documents at different timings. And normally those informal reviews, as I said, because they're informal, they are not timed, so randomly people can come and see and they can do an audit. Whereas these formal reviews, and one which is actually done at this requirement validation stage, is a formal review, where you as a producer of this document, you will present your document in front of a committee, which can be, I don't know, the QA manager or your project manager, or maybe there would be some representative from the client as well. They will all sit together, and you are going to present this document. You're going to explicitly go through all the functional, all the non-functional requirements, and the purpose would be to identify the problems. Okay, so the output of this formal review is the list of problems, and then you meet again to actually try to discover or try to find solutions to these problems. Okay, and list down that what are the actions you need to take to actually resolve all these problems. So what is this review process and this is actually true with all the formal reviews, that what we do is that we plan a review, okay, we distribute all the documents, and then we prepare for review and hold review meeting, follow-up actions, and revise documents. So normally what happens is that as I said, that because this is a formal review, as I said, that because this requirement review process, this is a formal review, and all these formal reviews, they are timed. And by timed, I mean that they are already planned. So as a project manager, he would have in his plan somewhere that we are going to conduct a formal review of this software requirement specification document. And normally these formal reviews are conducted when some main work product of the system is ready. And as I said, that software requirement specification is one of the key work products. So when SRS is ready after the specification process, we would have already planned this formal review of this SRS document. So, and as I said, but there are three key inputs to this review process. We said that SRS is one input, then we have organizational standards, and then we have organizational knowledge. So we are going to distribute all these documents. So first thing that would be done is we need to identify all the people who would be part of this review. So for example, let's say we have these people A, B, C, D. So these are the 4 people who are going to be in that review. So we need to distribute these documents to all these people. So we need to give A, B, C, D, all these people, all these set of documents. So they will go to these people and they will prepare for this meeting. And they would come prepared in that meeting. They would have already gone through that document. And when you are going to present your SRS, they would be actually be aware of what's written in it. And they would already have their perception about things, and they will, the idea would be to identify and to figure out that, if there is a problem in a statement. And then this review meeting is held, and then follow-up actions are decided. So if, for example, at the end of the review meeting, your SRS is absolutely fine. So there are 2 possibilities here, that SRS is absolutely fine, then, your requirement document is validated and it's fine. But if you realize that no, there are lots of problems in it, then you need to look at all the follow-up actions, and it depends on the problem that what sort of follow-up action would be decided. If there are lots of problems in your document, then you would have to go through another review again. But if the changes are small and the review people who are part of this formal review process, they have actually figured out, okay, these are very small, for example, typing mistakes, then you will just be told, okay, fix these problems, and then, this is our final SRS document. So if there are lots of problems, then this revised document will be reviewed again. But if there are not, then that would be the final set of validated requirements. And as we said, that within your SRS, you might find that, for some requirements there are lots of corrective actions, but for some there may not be, because we are saying that we are going to go through each one of the requirement in detail. So this is a flow chart of the requirement review process. And as I said, this is a formal review, and this is already planned. So what are these review activities? As we said, plan review, the review team is selected, and the time and place for the review meeting is chosen. So this is already planned for. So as I said, we identify the people, we decide where we have to meet, and we book a meeting specifically. And when we say distribute documents, the requirement document is distributed to the review team members. We say that the document is distributed or sent to all the people who will be part of this review process. And preparing for review, individual reviewers read the requirement to find conflicts, omissions, inconsistencies, deviations from standards, and other problems. So people would look at all these that document, and they will try to figure out on their own what they think are the problems, so that when all of them would come and sit together, then the idea would be to actually also find solutions, or also identify what are the corrective actions to these problems. And then hold review meeting, individual comments and problems are discussed, and set of actions to address the problem is agreed. Follow-up actions, the chair of the review checks that the agreed actions have been carried out. And revised document, the requirement document is revised to reflect the agreed actions. At this stage, it may be accepted or it may be re-reviewed, as I already said. That it depends on the initial changes. If there were lots of changes, then you might have to go through another review process. But if there were very small changes, and then it would be fine. You don't have to go through the review process again. So what are the possible problem actions, or what are the agreed upon actions on the requirements that you have identified at this stage? So now you can be asked for requirements clarification. So for example, the requirement may be badly expressed or may have accidentally omitted information which has been collected during requirement elicitation. So for example, you have written that you need to generate a certain kind of report, and you are trying to mention that, okay, this report should be generated on every dash of the month. Okay, So you had to mention that whether this report, which date of the month or which day of the month it would have to be generated. And for example, by mistake you actually missed that. So people would ask you, okay, is there something you're missing here, or you actually don't know it? So you would be asked for clarification. Similarly, missing information is something similar as well, which say that some information is missing from the requirement document. It is the responsibility of the requirement engineers who are revising the document to discover this information from system stakeholders. So as I said that, one problem was that you have not clearly specified it, and the other problem was you have actually completely missed the information. For example, you have completely missed that this report has to be generated twice a month or 3 times a month, or you have completely missed the information. So there are two possible scenarios. If there is any clarification, then it might be resolved right then and there. But if some information is missing, then the requirement engineers, they need to go back and talk to end users from whom they elicited these requirements. Then we have requirement conflict. So there is a significant conflict between requirements. The stakeholder involved must negotiate to resolve the conflict. So let's say even after going through the earlier negotiation process, you were not being able to resolve a particular conflict, and it still shows in the SRS document. Then you need to again sit down and have proper negotiation to actually resolve that. So final problem action is for unrealistic requirements. So let's say people actually identify that some of the things you have written in the document, they cannot be achieved within an amount of time and resources that you have. So for example, you have promised too many things, and you do not have the budget for it, and you do not have the time for it. So you would have to actually figure out, that okay, this cannot be done, and so you need to actually go and talk to stakeholders again to actually say that these are unrealistic requirements and they cannot be done. So these are the possible actions which can be taken. So we have said that there can be requirement clarification, something you have written which does not make any sense. You have omitted some information, and there are conflicts, and finally you have written some unrealistic requirements. So how do you actually ensure as an analyst before the review that your document is worthy for this review process? And why we actually need to ensure that? Because these formal reviews, they're expensive. Why they're expensive? Because as I said, they're already planned, and we have booked the time of lots of different stakeholders, and they have to sit with us, they have to they have to come for their meeting, they have to prepare for those meetings. So you want to present something to them which is of acceptable quality, okay? Because as I said, that client may also be involved in those meetings, so you don't want to give them a bad impression. So you need to ensure before the review that your document is actually good enough. So why we do this pre-review and how do we actually do it? As I said, that these reviews, they are expensive because they involve a number of people spending time reading and checking the requirement document. Now, these SRS documents, they are huge for some products. For imagine a project for 2 years or 3 year long project, these SRS documents, they would be of hundreds of pages. And so this expense can be reduced by using pre-review checking, where one person checks the document and looks for straightforward problems such as missing requirements, lack of conformance to standards, and typographical errors. And document may be returned for correction, or the list of problems distributed to other reviewers. So normally this is a practice which lots of more mature organizations, they do, that they have proper software process engineering groups, or they have SQA teams, and it would be their job to conduct those informal reviews, as I just said. And the idea would be that rather than asking too many people to come and conduct that formal review, you would ask one of your own team members to actually go through this document and try to figure out, because missing information and requirements where you need some clarification and typing mistakes, these can be identified even by your team members. So you don't need lots of very experienced people sitting together to actually review your document to identify those kind of problems. So it is always a good idea to go through this pre-review before actually conducting that formal review. So how do we do this pre-review checking? So again, you have prepared this requirement document, and again this requirement document is a complete requirement document, and so there are few things that this pre-review checker would do, or the guy who is responsible for performing this pre-review. What he would do is he would check the document for structure, he would check document completeness, that, for example, you were using a certain kind of template. For example, you were using IEEE template that I showed you guys in one of our earlier lectures. Now there are different sections in that particular template, and let's say you have modified it and you have changed it according to your organization or your client needs. Now when the person responsible for this preview, he would check your document for structure. He would also check your document for completeness, whether you have missed some information on your template. And then you would also look at the document against standards. So your organization has some standards, or the client for which you are producing this particular document, he might have some standards. As I said, that at times clients are very particular, and they would give you their own templates that we want SRS document written to be in this fashion. And so you need to ensure that whether your documents conform to those standards which you had to follow and which the client actually constrained you with. And then you have some automatic checkers as well, which you can run and try to figure out, whether what are the problems with it. For example, a very simple automatic checker is to identify, whether there are any spelling mistakes or whether there are any grammatical mistakes in the document, and you can use Microsoft Word for that. So at the end of all this pre-review, the person responsible for this pre-review, he would generate a problem report. And this report would contain all the things that is wrong, and then the person or the producer of this document, he would have to go through these changes, go through these list of problems, and he would try to resolve these problems and then go for that formal review. So again, this pre-review is not a replacement for formal review, but this is just to ensure that when you're going for formal review, you're very well prepared for it. And you only have those kind of problems in the document which you cannot find solutions for. Right? So that is the purpose of this pre-review process. So I think that is it from today's lecture. We are going to continue with our discussion on requirement validation in our next lecture, but let's quickly summarize what we have done or what we have discussed today. In our lecture today, we started our discussion with, we continued with our discussion on specifying non-functional requirements, and we looked at specifying these requirements for critical systems, and we said that there are 5 key non-functional constraints we need to worry about for critical systems, and they include reliability, they include performance, number 2, include security, they include usability, and then finally we said that they also include safety. And we discussed the importance of mentioning all these constraints in a quantitative fashion. In terms of reliability, we said we can define or we can specify reliability in terms of availability of the system and the failure rate of the system, or what is the acceptable failure rate of my system. So we need to quantitatively describe that, for what portion of time my system won't be available. And similarly, we need to describe the failure rate of the system in terms of mean time between failure or rate of occurrence of this failure. Similarly, when we talked about performance, we said that the performance can be specified in 3 ways. We can say that what are the timing requirements, what are the throughput requirements, and what are the response requirements. Okay. So for example, whether if our system has to produce some output and it has to produce that output at a given time, or it has to take some input from some sensors, for example, at a given time, then our system should perform in a fashion that it does not actually miss those deadlines, because if it does, we are talking about critical systems. So we need to very clearly specify that what is the frequency, or at what times. For example, we need to specify that our system has to poll the sensor 6 times every second. So we need to actually quantitatively describe it. And if what are the throughput requirements, we said under performance, we said that we will very clearly describe that how many transactions my system should process in a given amount of time. And then we talked about security requirements. And again, we said that in terms of security, we talk about that we don't want any unauthorized access to my system or to the data of my system. Again, we said that we have all these requirements for all the systems, but when we talk about safety critical system, we need to put a lot more detail in it. For example, we will talk about taking backups, we will talk about encryption on our data, and all these things when we are talking about these critical systems. Finally, we talked about usability, and we said that there are certain usability metrics through which we can determine that whether my system is usable or not. We can check the likability of my system. We can conduct surveys for it. Similarly, we can identify how many errors end users make using my system. Similarly, I can also look at the learning rate of my system, how quickly people get to speed with using the system that I have made. And finally, we talked about safety requirements. And we said that, you know, we know the scope or boundary of the system, and we will try to identify, you know, that what are the things that my system should not do. So for example, we looked at a particular example where we said that our machine may have to give a sedative to a certain patient, and the amount of sedative given to a patient should be according to the quantity should be described by the physician, and our system should ensure that system does not actually increase or go beyond that particular limit. So that is a safety example, and we talked about it that generally it's a very vague term, and there is no formal definition of what safety requirement actually means. And so that was, and towards the end of our discussion on non-functional requirements, we looked at the checklist of non-functional requirements, and we said that it is a good idea to have that checklist in front of you, and looked at the SRS document, which will help you identifying if you have omitted some key information. So that was our discussion on non-functional requirements, and then we moved on to validation process. We looked at what are the inputs and what are the outputs of this validation process. We said that there are 3 inputs to this validation process. We have the requirement document, we have organizational standards, we have organizational knowledge, and the outputs of this validation process would be some actions that you have to take on the problems that you have identified in the final SRS document. But a very key difference that we identified between validation and analysis is that during analysis we try to figure out, or we try to answer the questions that have we got the right requirements, whereas in validation we say have we got the requirements right. So there is a very small difference, but it is different because in analysis we are looking at raw requirements which we have elicited from the end user, whereas in the validation process we are trying to validate our final requirements. We are trying to validate the software requirements specification document that we have produced. And another thing that we discussed in our lecture today was the review process, or the requirement review process, which we said it's a formal review where it's a planned meeting which you have already decided that which people would be involved in that meeting, and all these people are given that requirement document. They go through it, they identify all the problems in it, then you meet on a scheduled time, and you try to resolve and try to identify all the problems and decide how you're going to fix those problems. So that is it from today's lecture. Inshallah, we'll continue our discussion on validation process in the next lecture. Take care. Assalamu alaikum.